This is part 2 of the lecture covering the simple pendulum. This lecture is specific to conceptual physics AB. Let's go ahead and take a look at a second example involving the simple pendulum. And this will be an application example because now what we'll think of the pendulum, we'll think of it as a clock. So let's take a look at the following problem. Please copy it down into your notes. Okay, a simple pendulum is arranged as a timing element in a clock. How long should the length of the pendulum be such that the period is exactly 1 second? This is part A of the problem. Okay, so recall from the previous lecture that the period of a simple pendulum is described by the following expression, where L is the length of the string. In this particular case, we're given the period of the oscillation. The period is 1 second. We then have to figure out what the length L is going to be such that we could use this pendulum as a timing element. So we're given capital T is 1 second. So now what I have to do is a little bit of algebra here to solve for the length L. The first thing to do is actually to get rid of the radical sign here. We'll do so by squaring both sides of the expression. So on the left-hand side, I'm going to get the period squared, and then now square the 2 pi, which is 4 pi squared, and then square the square root of L over G, which now just gives you L over G, like so. And now what we solve for here is just the length L. So cross multiply the G to the other side, divide by 4 pi squared to the other side, and that then gives us the length L. So the length L then is equal to the following quantity. And now we'll go ahead and just plug in the numbers, and when we do, we'll end up with a length in terms of meters. So I have G, which is 9.8, and then times 1 squared, and then divide that by, use parentheses if necessary on your calculator, 4 times pi squared. So when you do the math here, you end up with the length L as being 2.2482, we'll say, meters, like so. Now I'm going out here several decimal spaces in my calculation, and this is specifically for part B of the example. Let me go ahead and move my file. Okay, so now it says, suppose that the length of the pendulum was shortened by only a half a millimeter. Half a millimeter is next to nothing in terms of the length. What effect would this have on the period? As we'll see, its effect on the period is going to be considerable, especially as time goes on. One of the early problems associated with building pendulum clocks was making sure that the length of the pendulum itself was the proper length in order to record the time accurately. So in this particular case, what we're going to do is we're going to get a new length. I'm going to call it L prime just to give it a name. This is equal to the length L minus a half a millimeter. Now a half a millimeter is 5 times 10 to the minus 4 meters. So then think of it in the following way. The length L minus 0.0005 meters, like so. That's 5 times 10 to the minus 4 meters. That's a half a millimeter. So now let's go ahead and take 0.2482 and subtract from it this value here to get the new length L prime. So 0.2482 minus 0.0005, and this ends up being a length L prime. Let me do it here on the lower board. That's equal to 0.2477 meters, like so. And now let's figure out the new period. I'll call this capital T prime. So capital T prime, the new period is 2 pi times the square root of this new length divided by G. Let me now go ahead and do the math. So I still have L prime here in my calculator, so I'll divide by G, take the square root of that, times 2 times pi, and this then gives me a period of 0.9989 about seconds. So it's only off of a second by a little bit, but keep in mind that this error associated with this clock is going to build up over time. So over the course of just 24 hours, you'll begin to see a noticeable drift in keeping track of the time with this inaccurate clock as opposed to the earlier clock, which we'll consider to be accurate. So once again, one of the problems that early clock makers faced was accuracy, making sure that the length of the pendulum was exactly just right such that they could record the time necessary as accurately as possible.